Alright, on question number 1 here, we see that it's launched at 23-degree angle, and that it's launched at 123 meters per second, and so we can do our little cosine of 23 times 123 will get us 113 meters per second in the x. So that's the answer to that part. Then you do the same thing with sine. Sine of 23 times 123 is 48. So sine of 23 times 123 gives you 48 meters per second. This was cosine of 23 times 123. So that is your x, and that is your y. Not drawn to scale, of course. How long will the cannonball travel upward before it stops? So it's asking you. So 48, remember, is the initial velocity in the y. And it's saying the final velocity in the y is 0. So we have an initial y and a final y. So we can use VF equals VI plus AT there to get that 0 equals 48 plus negative 9.8 t. I'm going to make it down negative, as I often do. So 48 divided by 9.8 will get me the time that it takes to go up, which is 4.9 seconds. I'm going to go ahead down here and answer this question now. It's going to fall down to the same elevation that it started at, so that we can just double the time to figure out the new time for the total time in the air. How high it will be when it stopped, that's a dy. Remember, anything in the y is accelerated, anything in the x is not. So we can use vit plus half at squared for this one to get the initial velocity of 48 times the time, just the time to go up. Again, we don't care how long it takes to go down if we're figuring out how high it gets. Plus negative 9.8 times 1/2. I kind of flipped those around. Times t squared. And if you do all that, I believe you come out with about 118 meters for the height that it gets to. And so how far from you will the cannonball land? You got to be careful. This is not asking you how far it's landing from the cannon. It's asking you how far from you. So you're sitting right here, hanging out. Oh wait, that's not you. That's Greg Cribb's mom. And now the cannon. So you're 250 away. You're 250 away. And the question is, how far from you did it land? So we do need to find this total distance that it goes in the x, which we always get by taking Vx times t. And we have both of those parts. We have Vx is 113 from before, and t, total time in the air, is not just the up, because it also travels in the x while it's going down, 113 times 9.8. And so that turns out to be just, depends on how many sig figs you use. I guess we can only justify a couple of sig figs, so 1100 meters. And 1100 meters is how far it goes from where it was launched, but I am 250 away from it. So if I am 250 between me and the cannon, but it goes 1100, so 1100 minus 250 is how far from me it lands, which is where I got the 850 meters. Should you have moved when the cannonball was fired? Explain why or why not. The answer is yes. I should have moved 850 meters that way because I enjoy dying. Yes, there you go. That is the first problem. You can pause it and work with that. I'm not going to make several. I don't have time. I don't have time to make a bunch of different videos. So I'm going to go ahead and make this all in one video. We've only got 2 more problems. This time, the cannon, same distance from you, but this time you're both sitting on 200-meter tall walls. This is sort of like the 2 towers thing. Cannon is pointed directly at your head, theta equals 0, so you have the cannon on the tower, and here's you. It's pointing directly 0 degrees at your head, so it's going to be launched only horizontally. The cannon comes out at 214 and is horizontal. So all of its velocity is horizontal. So the horizontal velocity is 214. If you don't like that, how about this? Cos theta times the hypotenuse of 214 is, oh my goodness, it's 214. What is the cannonball's initial vertical velocity? Well, it's going horizontally, so it does not have a vertical velocity. What should you assume that you do, assuming that you wish to remain alive? So we have to change it from the last problem. Last time we enjoyed dying, but this time we want to stay alive, so it's going to be more complicated. So we basically have to figure out, there's a couple of scenarios. Either it's going to hit me in the head, it's going to hit me, or it's going to harmlessly fall into the strong tower below me. I suppose it would depend. If it hits the tower below me, let's assume that the tower is going to be strong enough to withstand the cannonball. So we essentially, what we're really interested in is how far it's going to fall. So I am 2 meters tall. So if it falls more than 2 meters, then that's good. That means I'm safe. If it falls fewer than 2 meters, that's bad. That means it's going to hit me. So that's the basic idea here. So I'm not going to do this problem all the way through. I'm going to let you ponder that, calculate how far it's going to fall. But you say, how? I can't figure that out. Well, you could figure that out if you knew the time that it fell, right? If you knew its initial y velocity, which it's horizontal, so you, oh goodness gracious, if you knew this initial y velocity and the acceleration and the time, you could figure it out. So really, the time is the key here. I think you know all those things. D vit plus half at squared would get you how far it falls. The time is all you need. Well, if only you knew the time. How do you know the time? Well, you can find the time real easy. You know the dx, right? Yeah. It's where is it? Where is it? Oh wait, it's the same as the last problem. It's the same distance from you. So the last problem it was 250. So 250 meters, and you know Vx. If you know dx and Vx, I think you know a t. So blah blah blah, figure it out, come up with your answer. That's all I'm going to say about that. For the final, for my final trick, we have an asparagus. Everybody likes asparagus. So let's do a problem with it. This time I'm on a cliff. I have an asparagus. I'm going to throw it off at 18. I guess this problem is not very well written. I'm sorry, it's not very good written. It doesn't say this, but you need to know this to do the problem. It's thrown horizontally, so it's thrown straight off of the cliff. It's not arced up or down, it's straight. So we're told that the dx then, and we're given the vx. So just like the last problem, we can find a t. And if you have a t, there's all sorts of things. I'm guessing you can find the height of a cliff if you know the initial velocity, the acceleration, and the time, which you just got the time over here. So yada 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 yada. That's how you do that. So I kind of gave fewer and fewer information out with each problem, but that should be enough. Don't call me, don't FaceTime me until you've watched this and still can't find the beehive.